Welcome, everybody. This is the Rotary E-Club of Silicon Valley, and every week we bring you the stories of people who are making life better for others around the world. This is part of Service Above Self, Rotary International's motto. Rotary is 1.2 million people in 36,000 clubs all over the planet. And some of those clubs are a little different. Ours is one of those. The Rotary E-Club of Silicon Valley is not only online, it is also asynchronous. We post our meetings early Monday morning, and they're available all the way to Sunday night, U.S. Pacific time. That flexibility is something we consider is important. We also have the wonderful byproduct of that we get to talk to people all over the world because our speakers are recorded messages just like the one you are now watching. And so we love that opportunity to really tap into the international aspects of Rotary's interest in service near, far, and everywhere. Today, we are going to be talking with John LaRocco, Qudsia Tahmina, and we'll also have John Simonis with us, all of the Ohio State University. They're going to talk to us about water possibilities in ways that you may not have imagined. We are excited to have them here. If you want to read their full bios, feel free to pause this recording on the page where you found it and read the gory detail there. Otherwise, let's get started. John, welcome to the Rotary E-Club of Silicon Valley.
Thank you very much. So today we're going to talk about our paper, comparing elastocaloric cooling for atmospheric water harvesting with myself and two of my co-authors, Professor Qudsia Tahmina and John Simonis. So a brief overview and a picture of one of our prototypes. So clean water is accessible to at least a quarter of the human population. Desalination needs a coast with an ocean and a lot of energy and infrastructure. And conventional dehumidifiers are very energy intensive, which we'll discuss a little bit later. But overall, how do we make clean water available for people who might not have access to either a coastal desalination plant or costly and bulky dehumidifiers? So that's what we wanted to compare. Economic ways to give clean water from the air with the minimum needs for power input. So desiccant wheel technology is used in HVAC, heating, ventilation, and air conditioning, which basically involves a wheel full of desiccant, like silica gel, heated on one side, cooled on the other, and spun around. And this creates condensation that pulls moisture from the air. Now, because you're spinning a large drum, it requires a motor, a heater, and a lot of energy. Now, that's why desiccant wheel technology, the current thing used in dehumidifiers, air conditioning, and heating, is so costly energy-wise and size-wise. In contrast, elastocaloric cooling is relatively new technology and at least twice as efficient, according to the literature, as desiccant wheel. It uses materials like nitinol wire, NiTi, nickel titanium alloy, which can change shape or contract or expand when exposed to temperature differences. But how do we compare a similar desiccant wheel size system and an elastocaloric system with identical humidity and energy input conditions? Which one will do the best? That's what we wanted to compare. So we devised a method for tracking power use. John Simonis here did much of the lab work, but we compared desiccant wheel and elastocaloric cooling in a chamber with constant relative humidity, 99%, kind of the ideal case for power for atmospheric water harvesting. And how much power does it take to harvest water per volume per hour? We conducted 3 tests about half hour each. And the way our system works, I'm not sure if you can see the cycle of the system there, but overall, first, a crankshaft and a motor moves that shuttle to the right on the little diagram here. And at maximum extension, the water forms a micro temperature gradient, or rather the wire does. Water starts condensing along the wire that cools it off and snaps it back, and the water runs off. And then the cycle starts again. So that's how our system functioned. Now, my colleague Qudsia will take it away from here.
Thank you, John. So we developed a testing protocol and applied to evaluate the harvesters. Both the prototypes and the control assemblies were positioned within an enclosure, as you have seen the picture, equipped with a continuously operating humidifier. Reading off of the system, systematically we collected data at regular intervals of 10 seconds, such as current, temperature, water level averaged over the time frame. Once we did the averaging, the measured values were basically mitigated and the potential outliers were identified, and any impact of noise from the experiment was also evaluated. So as John L. mentioned, three tests were conducted for both the controls and the nitinol prototype assemblies over a cumulative duration of 30 minutes. Based on the efficiencies reported in earlier work, we hypothesized that the elastocaloric device would achieve a higher water harvesting rate at a greater energy efficiency. We were also monitoring the energy efficiency at that time. So the temperature, power usage, and water harvesting rate were compared for both the desiccant wheel and the nitinol prototype. And we saw significant differences between the power consumption over 30 minutes. So the desiccant wheel, as you can see, the harvester accumulated a total water volume of 15.67 milliliters, which was also shown in our paper. And the average harvesting rate was about 0.15 milliliters per watt hour. The nitinol wire harvester that we tested, it collected about 9 milliliters of wire. However, the volume fluctuated slightly. So the average harvesting rate for the nitinol prototype was about 0.18 milliliters of water per watt hour. However, the total watt hours are almost half of those that desiccant wheel design used. So on average, it was basically proven that nitinol harvester was significantly more efficient than the desiccant wheel harvester. The next slide, please. So while fatigue and other factors were involved, the nitinol wire prototype remained a potential winner in this case. However, there are other things that we have to be considerate about thermoregulation that was an advantage for this device. Beyond the atmospheric water harvesting, nitinol dehumidifiers could be more energy efficient options in the future for HVAC, water heat management, or I'm sorry, waste heat management in computing, freezing, firefighting, refrigeration, and so on. Iterative improvements are required basically to refine this method. However, we can see some energy efficiency in the long run. So in summary, elastocaloric cooling remains a significant advancement in the dehumidification world and something that is economical and feasible. Now I would like to have John Simonis take over.
Okay, well, following up on everything that's been said so far, basically in conclusion, we found that this has the potential to solve one of humanity's key problems when adapted to a larger scale, mostly due to the modularity of the project, as well as just the general availability of most of the components available. And it has very large implications in the worlds of energy, HVAC, healthcare, and related industries. And here we just have a simple chart here that just kind of shows a general trend of our data with a most accurate equation that was actually fit with symbolic regression. The idea behind that was to essentially figure out if we could see if there was any major trend in fatigue, which is likely where our research is going to go into the future. But other than that, any questions?
We will certainly have some questions. Before we get to the Q&A, though, I'd like to introduce the group that we have got. So, if we could stop sharing for a minute, I'll move us to gallery view, and that will allow us to say hello to the folks who are there. If you If you would, just wave at the camera when I call your name. From our club in Eastern Italy is Cecilia Babkirk. Visiting us from Budapest, Hungary is Victoria Griesmuller. Good to have you both. My name is Rushton Hurley. I'm in San Jose, California, and excited for us to get into the questions for this. And so I'll start with this. When we look at this kind of approach to pulling water from the air, which parts of the world are most suited to the techniques that you've described? I mean, I assume humidity is an issue, but are there a variety of factors that allow for certain places to be better for this than others?
Well, places, it's relative humidity that's the key here. Of course, tropical regions like, say, West Africa or Southeast Asia or the Caribbean might come to mind, but also might be, say, the Pacific Northwest, the Great Lakes, places where there's a lot of water in the air, even if it makes it colder instead of more humid. I know talking with humidity can be a very sticky situation. Otherwise, we'd be hung out to dry.
Uh, all right.
We
Well,
got some in the chat.
we
Mhm.
do, we do. And let's start with the one that Cecilia asked about this technology and its use commercially. Have you partnered with any companies that are using this at any particular
Well,
point?
this technology is being commercialized for air conditioning in Hong Kong right now, to my knowledge, but not yet for dehumidifiers, at least in the water harvesting context. We have had many companies approach us, but this was basically a glorified undergraduate project
Mhm.
that we did at one of Ohio State's satellite campuses, Marion, which does a lot of the hands-on manufacturing stuff. And John here was the one who executed the investigation, shall we say.
Yeah, kind of adding on to that, right now our project is currently in a phase where it's proof of concept, but the foundation is kind of there for us to take it further should we choose to work with a specific company in a specific industry where we can adapt components of our project more toward something that has like an HVAC related purpose or something that's purely related to water harvesting. But a benefit of having this research out in the open is we can have feedback, which is something that we have gotten a lot of from some of the companies that are out there, as well as getting feedback from other researchers who may have tips or may have constructive criticism on the way in which we can improve some of our testing methodologies in the future.
Excellent. I wonder if you could talk to us a little bit about the standard process. You know, John L., you mentioned that you'd been approached by several companies. Is this a typical part of how this kind of research works? That you're getting papers out there, different kind of companies are contacting you and saying, "Hey, we'd like to work with you at some level on this." For people who are not in academia, what is it that you see as kind of the standard process for taking a good idea from research to prototype to commercial possibility?
Well, in our, at least the way Ohio State does it, is that there's a technology commercialization office. If university funds are used for a prototype like ours, the university patents it. The inventors like John S., John L., Qudsia, and myself, we are all kind of shareholders in that process. But overall, it's like if there's a company who would like to lease the patent and build on our technology, they would go through that office as opposed to just doing it, as opposed to just contacting like one of the researchers directly. They might contact us early on to if they're curious about how it works or a feasibility of scaling it for a particular application like we have. But overall, it's more like there is a process for how an industry will have a need. The industry already has a problem. It could be a government agency as well that has an issue that they think our patent or our technology could solve. So they might go through the technology commercialization office or something comparable in other universities.
Right. Kind of following up on that, they kind of essentially act as like a middleman or a broker, where you have these people that are essentially shopping around for these technologies already that can solve these problems. And then basically our middleman in this case, the TCO, can negotiate with these companies on a specific deal or a specific licensing structure, which makes it really easy for us, the inventors, to kind of have a relatively hands-off approach when it comes to dealing with some of the more intricacies of that kind of licensing deals, while focusing purely on the technical side of things.
And also adding, piggybacking on the academic side of things, I just wanted to mention that faculty members at the institutions collaborate with the researchers, and if there comes an idea that is worth investigating, undergraduate students or graduate students are proposed, we propose these ideas, and we, as long as students are interested, we continue with this idea. And with Ohio State Marion being one of the regional campuses, we do have all the resources available for our students to take part in research activities and be involved in not only working with us, but also publishing with the faculty members. So once the idea or the paper gets, out and it is, read by a lot of researchers, our talent acquisition or even the commercialization office reaches out to us with a proposal to submit a provisional patent. And that's what happened in our case.
Got it. It seems like one of the values that your team brings to this is a lot of international experience. John L., you mentioned the connection with Hong Kong and the work being done there. I know that projects that you and perhaps more of you have been involved with have been in Singapore and in South Korea. Can you talk about the international connections and how they support the kind of work you're doing and essentially bring more possibility to advancing the technology in interesting ways?
Well, in this case, I simply worked in industry when I lived in Asia, and I like to follow on what's going on research-wise in other parts of the world. A lot of times, change doesn't come from the center, but the periphery. I know it sounds, and then it gradually moves over years as a new standard takes over. In economics, politics, philosophy, technology, it's a classic dialectic. The core and the periphery are interconnected in ways that don't always make sense at first. But in our case, we are at Ohio State, right in the middle of the American heartland. We're not on the coast, so being aware of the stuff that's going on in other parts of the world, when many of the more established schools and research groups on the coast have their own directions they're already kind of going in. Being aware of the unconventional approaches is kind of something my colleagues and I have been doing for a while.
It seems like there is an orientation to what strikes you guys as cool. Like that being aware of what happens in different places is also a matter of looking for those things that you're excited about. Can you speak at a very basic level about science education and getting people, I'm sure finding people like John S., to be part of a team, is a function of getting people excited about scientific possibilities. And is that something that you and Qudsia that you have done at The Ohio State University in a way that you feel has been especially successful?
Yes, I'm an advisor for a club called Neurotech that's half engineers and half medical pre-med students. And I basically give them ideas for crazy hobbyist projects like a foam that a better impact absorbent foam, for instance, that turns into methods papers or research publications to get them experience with project management and academic publishing. But even more than that, I'm a science fiction fan, and I like to build the inventions from all the classic sci-fi stories and make them come true. So that's the real goal of a lot of our crazy research. Learn what's already in the popular consciousness and make it real in a way that most people are unaware that already exists, even if the technology's been around for decades in some cases.
Mhm. And I would like to add that me being a faculty member at Ohio State, I have always been an advocate for science education, and we do run summer camps on our location, and it has been a pleasure working with the students and spark that interest among them at early age. starting in the middle school, that's where most of the students are making decisions about their career pathways. So I think with these summer camps and outreach activities that we, offer at our campus, it has been a huge, like a positive, impact on not only on the students but also on the community to impart education about science and engineering.
So, Qudsia, let's stay with you for a minute. The work that you have done leading up to this kind of thing, or parallel to this kind of thing, where it has to do with prosthetics and cochlear implants, right? You're, I
Mhm.
believe, a researcher in brain interface technology.
Yes, yes.
When you think about this wide variety of things that you're interested in, John L., you too. I mean, this long kind of list of interests. How does that allow you to make what you're doing all the more successful? So what I'm trying to like point at here is that you're bringing, essentially a certain variety and attitude to the work you do that seems to be really exciting, something that probably John S. can talk about as someone being on the receiving end of it. But I'll open it up and Qudsia, have you start.
Yes, thank you so much for asking that question because that all ties back to the enthusiasm and the passion to do your work. And I think it all started, when I was doing research, as you mentioned earlier, in my PhD dissertation about the cochlear implant. And I was so motivated to see how technology can impact not only, the general population, but especially who are in need. So I think having that passion to support one another and also to support the environment, that's something that has to be built and nurtured throughout your education. And that's what we are here for. And as I mentioned earlier, I just want to advocate knowledge about science and education to the students to make sure that they get interested. And sparking that interest at the early age is important because they have a long way to go. So I think what I believe is enthusiasm, passion for your work, and also perseverance. Um, as an engineer, there were a lot of points or times, when you fail, your prototype doesn't work, your product doesn't yield the results that you expect. But at the same time, having that perseverance to redo it, rework it, and make sure you are able to deliver the results. That's what we need in our future generation of leaders, scientists, engineers.
Fantastic. John L., would you like to chime in on that same theme?
Well, to build on what Kuzia said, passion drives a lot of it. As I can personally attest to, like my love for making science fiction concepts real and inspiring a bit of curiosity, but also making these projects cumulative, take aspects from a prior project and literally build upon it. Kind of like the tech tree in the game Civilization. You gradually work your way up to something much more impressive. I don't want to spoil anything, but we have a few of those projects coming out in the near future.
Very cool. John S., as a student in that kind of space, can you talk about your experiences working at The Ohio State University and getting the opportunity to get excited about research and career possibilities?
Yes. So I am absolutely positively thankful to have had the experience that I've had working at The Ohio State University because um, prior to my experience in research, I have been a maker for a very long time, but I haven't really had the resources behind me to make anything that was super large or super extravagant or something that actually has the capacity to change the world in a substantial way that I believe I have been given the opportunity to do with the resources provided to me by The Ohio State University. It hasn't just been me networking with wonderful people like Dr. LaRocco or Dr. Tahmina, but it's also been resources like being able to provide the parts for my next project, being able to provide me the resources and access to all of these other different resources that people have already prepared, doing research in different fields where I can expand my knowledge base and grow my understanding of different concepts that are before research, at least foreign to me, and also giving me valuable skills for the workforce that I previously didn't have. Things like technical writing, technical discussion, public presentation, basically a fundamental understanding of things like creating a bill of materials, basically working within a specific corporate structure. So basically understanding like, okay, who's responsible for what are my responsibilities? How do I interact with people who are doing a specific task for me? How do I interact when I'm doing specific deliverables for somebody else? It's very valuable skills like that that I think most people kind of take for granted, that you really get reinforced doing this kind of work as a student. And from an inspiration perspective as well, it's like being able to have this environment where you can work and explore these concepts in a relatively safe way while also making meaningful changes basically provides you with an opportunity that I don't think is really experienceable anywhere else as just an individual maker. It's been wonderful.
I think you're talking
Mhm.
about the opportunity to scale your interests in a way, right? To
Yes.
be in a space where you have the chance to take it to a next level and a next level and a next level. I love that that is both part of the scientific possibility as well as it is kind of the personal appeal. There's a great question in the
Mhm.
chat from Cecilia about that idea of scaling the technology specific to the presentation. So when we talk about water harvesting, there are places where there is a massive need in terms of water. So here in California, we have ongoing, unending discussions about how to get water into the places where they're needed and how to use water effectively. Is this technology a technology that can address those larger scale needs, or is it much more focused on getting potable water to people who just need it for health?
Well, our original idea was more of a backpack-sized unit for an individual person, right? A camper, emergency rescue, stuff like that. To scale it up to a city or a town or even a village, that's quite literally beyond our pay grade. That's for civil engineers to worry about, but we might have to complement it with other technologies in certain cases. But either way, it would a lot of it would depend upon the specific area, atmospheric humidity and stuff like that. But keep in mind, even in deserts like along the Sahara, they use what's called fog harvesters or fog nets, essentially clothesline-like arrangements of textiles that can grab a few drips of water. Not enough to sustain someone, but even in areas of relatively low humidity, these have been used since the Stone Age. So this kind of technology has already been scaled to a point for many human communities. It's just a question of how much can we do it economically in terms of the energy, the infrastructure, the actual water usage? Like if there's an invention that comes out that utterly reduces the need for water or some kind of hyper efficient water recycling, that would definitely affect our ability to say build a industrial elastical or cooling water harvesting facility.
That makes sense. I see that we're actually kind of winding down on time. There's still a couple of questions in the chat I want to get to, but as we always do, what we'll do is we'll take those on after we finish the recording itself. It's one of the benefits of being part of these presentations that we get to connect with such interesting people and spend a little extra time with them after we finish the recording. To all of you out there who have taken the time to watch this video or listen to this podcast, we thank you for spending your time looking to get inspired by possibilities, the possibilities of exploration, invention, scale. All of this fits within the realm of service as well. To what degree do we stop and brainstorm possibilities for serving others in our community, where we try things out and we learn from those possibilities and figure out how to scale what works so that we can reach more and more people in need? I love that that message is a part of what you bring. John S., Dr. Tahmina, Dr. LaRocco, it is such a pleasure to have you speak to us. And as we always like to do, I'll hand it back to you for the last word. I believe, John L., that is you. So what would you like people to have clearly in mind as they finish this recording?
Well, clean water should not be a pipe dream for everyone. Otherwise, it would be kind of draining.
Well, thank you for that. Thank you, everybody, and we will see you next week.